On February 7, 1984, high above our planet, astronaut Bruce McCandless stepped away from the safety of his spacecraft and floated freely into history. This was a monumental leap into the unknown. While the first moonwalk was a giant leap for humanity, this was a dive into the infinite. Space is vast, not just in size, but in its power to captivate our minds. The idea of endless nothing is difficult to grasp. Space is mostly emptiness, a potentially infinite void. Yet it is also filled with colossal structures and energies we can barely imagine. Immense threads of galaxies, each holding countless stars. Places where matter is so dense the laws of physics no longer apply. When we gaze upward, we only see the nearest stars. Everything else remains hidden in the dark, like some ancient, unseen terror. And still, we feel an irresistible pull toward it. Since the dawn of time, we have looked into that darkness, searching for purpose. We use stars to find our way and to plan our harvests. We saw our gods and stories written in their patterns. We may not have known what was out there, but we knew it mattered. We built telescopes to pierce the gloom, discovering strange new worlds. Today, we take our first careful steps into that void, wrapped in suits and machines that mimic our own world. We cannot survive out there. From this viewpoint, our planet is a tiny haven in an endless black sea, as insignificant to the cosmos as a single microbe in the ocean. Astrophobia is the fear of space and celestial objects. This can include the night sky itself. For someone used to city lights, seeing a truly dark, star-filled sky for the first time can be overwhelming. An astrology believer might feel anxious when Mercury appears to move backward. The old belief that a full moon drives people mad is also a form of this fear. But there is a deeper kind of astrophobia, a cosmic dread. Have you ever lain on the grass on a clear night and just absorbed the sky? Let it surround you until you feel a part of it. A strange feeling can creep in that you are not looking up but down. Below you is an infinite drop. The only thing preventing your fall is gravity holding you to the ground. This shift in perspective can be transformative, and it's something everyone should experience at least once. Some substances might enhance that feeling, but that's just an observation. In space, that perspective is more accurate. There is no up or down, only endless directions. Gravity, a force we still don't fully understand, is all that keeps us from falling forever. And if you were to step out into that void, you would only make it about 5 miles or 8 kilometers before you could no longer breathe. You could walk that distance in little over an hour. It's nothing. And everything beyond that point means certain death. A genuine fear of space is justified. We live on a thin layer on the surface of a small planet. Even here, we can only survive on land, which is just 29% of the surface. And of that land, only 43% is truly habitable. The rest will kill you with extreme heat, cold, or impenetrable wilderness. Earth itself can end your life in countless ways. You could die of thirst, drown, fall, be struck by lightning, consumed by fire or predators. A wrong choice of berry, a venomous snake, a disease-carrying insect, or a trip to Australia could be fatal. You could be destroyed by a volcano, poisoned by gas, catch a plague, or simply wait long enough. One way or another, Earth always wins. No one gets out alive. And yet, it is the only place in our solar system where we can live. If you found yourself on Mercury, you'd lose consciousness in seconds without oxygen. In the vacuum of space, your skin would boil as gases in your blood formed bubbles. On the sunlit side, you'd bake at 800 degrees Fahrenheit. In the shadows, you'd instantly freeze at nearly 300 degrees below zero. On Venus, you wouldn't even have time to suffocate. You would immediately ignite in the 867-degree air while being crushed by pressure 92 times greater than Earth's. It would be like the Titan submersible disaster, but engulfed in flames. On Mars, you might enjoy a relatively warm day, but you'd still suffocate. The air pressure is only 1% of Earth's, with almost no oxygen. You'd get the worst case of the bends imaginable before passing out. Landing on Jupiter is impossible because it has no solid surface, just a thick atmosphere that turns into liquid and strange states of matter. You would fall until you were compressed into something like a diamond. Saturn is similar, but breathing its ammonia clouds would sear your lungs first. Neptune and Uranus are so far from the Sun that their hydrogen atmospheres freeze solid. They are called ice giants, and you would become one within seconds. At nearly 400 degrees below zero, your body wouldn't just freeze, it would turn into glass. Our understanding of space's scale is warped because it's impossible to picture accurately. To show it to scale, you wouldn't see much of anything. Light takes 8 minutes to travel from the sun to Earth. It takes about 8 hours to reach the edge of our solar system. So one light day is 3 times the radius of our solar system. A light year is 365 times longer than that. Our nearest star is over 4 light years away. The North Star is about 450 light years away. The farthest star visible to the naked eye is a supergiant roughly 16,000 light years distant. We reside roughly halfway between the center and the edge of our Milky Way galaxy. From our position to the edge is about 25 to 28,000 light years, making the galaxy's total width roughly 100,000 light years. These distances are mind-boggling, but they are nothing compared to the gaps between galaxies. 5 million light years away, 25 times the length of our own galaxy. We are part of a local group of galaxies spanning about 10 million light years, which sits inside the Virgo supercluster. This supercluster contains about 100 galaxy groups, made up of 10,000 galaxies, stretching across 110 million light years. This, in turn, is part of the Laniakea supercluster, which includes Virgo and others, all flowing toward a region called the Great Attractor, spanning 500 million light years. Laniakea is one component of the Pisces-Cetus supercluster complex, a filament of galaxies a billion light years long. At this scale, the universe becomes a web of filaments and vast voids like the Boötes void, which is 300 million light years of pure emptiness. Beyond this lies the cosmic web, where our numbers fail. The observable universe is estimated to be about 93 billion light years across. Given this unimaginable scale, one might assume the universe must be filled with billions, even trillions, of planets harboring life. Even if the chance of life evolving around another star is 1 in a million, the number would still be astronomically large. The author Arthur C. Clarke once noted there are 2 possibilities. Either we are alone in the universe or we are not. Both are equally terrifying. If the universe teems with life, it means potential threats could be lurking everywhere. It also means we are not special. We do not hold a privileged place in the cosmos. We are not the universe experiencing itself. We are merely a strange fluke of organic chemistry devoid of inherent meaning. If no other life exists, then we are utterly alone, drifting in an infinite void, which, as one character put it, seems like an awful waste of space. Such a waste feels unreal, perhaps suggesting a simulation. What if this is all a vast game that generates itself as we explore? When the Hubble telescope took its deep field image, pointing at a seemingly empty patch of sky to find thousands of galaxies, perhaps those galaxies didn't exist until we looked. Maybe the universe's structure didn't exist until we learned to map the cosmic microwave background. Perhaps we are just code, and our consciousness is merely a program running in a simulation. This is a popular, if eccentric, theory, and belief in it is understandable given the baffling nature of reality. There is another possibility, one that allows for a universe full of life yet seemingly empty. It is no less existentially frightening. The concept of the Great Filter suggests that simple life, like bacteria, might be common, but intelligent life encounters barriers preventing it from becoming widespread. Some think this filter happens before intelligence arises. For instance, the jump from single-celled to multi-celled life. 5 billion years old, and single-celled life began relatively early, perhaps within the first half-billion years. Yet it took another 2.5 billion years for multicellular life to appear. This step might be so rare it acts as a filter. Others suggest the filter lies ahead of us after intelligence evolves. Perhaps due to a cosmic catastrophe, the death of their star, a predatory alien civilization, or because intelligent societies inevitably exhaust their resources and collapse. Maybe intelligence is not evolution's ultimate goal but a mutation, a kind of cancer that consumes unsustainable resources and dies out. This is a dramatic way of saying intelligent civilizations may have an expiration date. If space is absurdly vast, so is time. The two are linked. The average lifespan of a species on Earth is between 5 and 10 million years. Intelligent life might do better or worse. Let's assume we last 10 million years. 8 billion year history, that span is a line too thin to see. Even if life were common, even if every star system could produce intelligent life before its star died, it is entirely possible all those civilizations rose, flourished, and ended at different times, never knowing the others existed. In our tiny, fleeting oasis, we have only each other against the vast, consuming dark. On Valentine's Day in 1990, the Voyager 1 spacecraft, far beyond Neptune, turned its camera back toward home for a final photograph. This picture had no scientific value, it taught us nothing new. Yet from over 6 billion kilometers away, Voyager captured Earth as a mere speck of blue light. It is perhaps the most truthful portrait of humanity ever taken. As Sagan reflected from that great distance, Earth may not seem special, but for us it is everything. That dot is here, it is home, it is us. On it, everyone you have ever loved, known, or heard of has lived. All our joy and suffering, every religion and ideology, every hunter and hero, every king and peasant, every parent and child, every inventor and explorer, every saint and sinner in our history, all have existed on that mote of dust, suspended in a sunbeam. Earth is a very small stage in a vast cosmic arena. Consider all the blood spilled by emperors and generals striving to become temporary masters of a fraction of that dot. Think of the endless cruelties inflicted by inhabitants of one corner upon those of another. How frequent their misunderstandings, how eager they are to fight, how fervent their hatreds. Our posturing, our imagined self-importance, the delusion that we have a privileged place in the universe, all are challenged by this point of pale light. Our planet is a lonely speck in the enveloping cosmic dark. In all this vastness, there is no hint that help will come from elsewhere to save us from ourselves. Earth is the only world known to harbor life. There is nowhere else for now where our species could move. We can visit, but we cannot yet settle. Like it or not, for the present, Earth is where we must make our stand. Astronomy is a humbling experience. There is no better demonstration of human folly than this distant image of our tiny world. It underscores our responsibility to treat each other with kindness and to preserve our only home, the pale blue dot. Space is terrifying, yet we are drawn to it, the ultimate call of the void. With renewed interest in moon colonization and powerful new telescopes, we seek to stretch further into the abyss. Perhaps we will succeed. Maybe we will grow wiser and outlive our expected span. Maybe we will spread through the cosmos and find new homes around other stars. In an infinite universe, anything is possible. The sheer scale of existence is beyond our grasp, but our ability to learn and understand is not. If you enjoyed exploring these ideas, consider showing your support. Liking this video helps others find it, sharing it spreads these perspectives, and subscribing ensures you don't miss future journeys into the unknown. Your engagement allows this exploration to continue. Thank you for watching Our Stand Is Not. If you enjoyed exploring these ideas, consider showing your support. Liking this video helps others find it, sharing it spreads these perspectives, and subscribing ensures you don't miss future journeys into the unknown. Your engagement allows this exploration to continue. Thank you for watching.